In this example, we'll be looking at expressions that have expansion in it, and we have to simplify after we expand. So unlike our previous examples where we just expanded expressions, now there's going to be some more like terms added to it where we would have to simplify after we expand our set of parentheses. So in this expression, we have 4 times the sum of p and 5q minus 3q. Our first step here would be to use the distributive property to remove this set of parentheses. So we're going to take 4 times p, which gives us 4p, and then we're going to take 4 times 5q, which gives us a positive 20q. And then we're going to carry down our minus 3q. And now we want to look at our new expression, which is 4p plus 20q minus 3q. And I'm going to split the expression so I could identify my terms. I have a positive 4p, a positive 20q, and a negative 3q. We have a pair of like terms, the positive 20q and the negative 3q. I could combine those to get us with 17q. And then I'm going to bring down my 4p, and we are left with 4p plus 17q as our simplified expression. For part B, we have the same type of setup here. We have a negative 2 times 5/10 times the difference of 5/10 y and 3 plus y. We're going to follow the same process here. We would expand, so we're going to complete this part first. We have a negative 2 times 5/10. 2 times 5 is 10. There was 1 decimal place. So that would be 1.0y or 1y, and it was a negative times a positive, which makes this a negative 1y. Now inside our parentheses, we're left with a negative 3. So we have a negative 2 times a negative 3, which leaves us with a positive 6. And then we carry down our plus y. So for our new expression, we have a negative 1y plus 6 plus this y by itself means that it's 1y as well. If we're looking for our like terms here, or if we separate our terms to start, we have a negative 1y, a positive 6, and 1y. Negative 1y and a positive 1y are opposites, so they could cancel each other out. And this expression, when we simplify it, we're just left with 6 as the simplified expression. For our last example here, you'll notice it's a little different. We have 2 sets of parentheses. So we have 4 times the sum of 2n plus 5 minus the difference of m and 1. So we're going to distribute in 2 spots. We'll start with this first set of parentheses here, and we're going to take 4 times 2n, which would give us 8n, plus 4 times 5, which would give us 20. For the second set of parentheses, we have a negative sign outside, and it's touching the parentheses here. So we're going to distribute this negative sign. And from yesterday's work, we could have rewritten this as a negative 1 times the difference of m and 1, or we could just go through and distribute that knowing that it's a negative 1. So if I had a negative times a positive m, that's going to leave me with a negative m, And then if I have a negative times this remaining -1, that's going to give me a +1. Now I'm going to separate my terms from my new expression. We have 8m, a +20, a -m, and a +1. Our only pair of like terms here are the constants. 20 and 1 is going to give us 21. We have a +8n, so I'll write 8n. I'll bring down the -m and plus 21. So this expression would simplify to 8n minus m plus 21.